Hello, my name is Ivy Barvina. I am a technical and game designer with 6 years of experience building practical gameplay system, player flow, and UI logic. In this lesson, we will focus on a small but reusable interaction pattern in Unreal Engine. Our goal is to understand a structure that can grow into a production-friendly workflow, not to build a full game system. So let's frame what we will cover today and what we will have by the end of this lesson. The final result will be a small line trace based interaction prototype. The player looks at the object, checks what is under the site, the interface will display a hint for an interaction, and the player can press a button to trigger certain behavior on the object. To get there, we will cover enhanced input setup, line tracing and its calculation, receiving hit result and actor validation, interface concept in Blueprint approach, UI behavior, and a little bit of data types and variables. By the end, you will have a compact system that is readable, reusable, and easy to extend with new objects. Let's go to the engine. A few words about the project setup. I will work in Unreal Engine version 5.7.4. We start with a third-person template, Blueprint project type, without a specific variant. If you don't see pop-up window when you start Engine, go to the Home tab and click New Project. Here you need to choose a game category, select a third-person template, select project as Blueprint, target platform desktop, and quality preset maximum is fine on stronger hardware, and scalable is safer on weaker machines. The interaction system itself doesn't depend on the rendering presence, so choose by your hardware possibilities. Set variant to none, choose a path for a project storage, and give it a proper name. Then click Create. I'm already created mine, so I skip this step. When the project loads, let's check one basic thing. We need to be sure that when we click play, our third-person player spawns correctly and Pion can move. So now that the project setup is visible, we should add the small asset pack I've prepared for this lesson. Let's go to the content browser, click on the content folder, and select Show in Explorer. That brings our project folder in our Windows Explorer. Also, you need to open the place where you store your project assets and unzip it or double click to go inside. Then we need to go inside again and select Gameplay Teaching Lab folder and simply drag and drop it to our project folder. Then we need to wait a little bit when Unreal processes every asset and let's look what it's contained. The inside you can find a few meshes and materials for our interactable objects and pre-made UI widget blueprint with crosshair textures. And also it contains a few data structures, one enumeration for our interaction type, and a string table with a localization for prompt text. So let's talk about how interaction works. At a high level, a line trace means that we send a ray from something into the world, from the camera in our case. If the ray intersects something like line trace, return to us hit result data. And from this data, we can get a reference to the object that the ray intersected. And the link already allows us to do whatever we want with this object. It would be a good practice to divide responsibilities in the system. The player owns input and detection. The object owns its reaction. That means the player knows when the interaction key is pressed, and the player performs the camera trace. A pickup decides how to pick itself up. A changeable object decides how to change its own material. And the blueprint interface is the contract between them. So the architecture is player triggers an event by input, event triggers a camera detection line trace check the intersection with object and check if the object implements interface, then we can trigger the reaction on this object. This keeps the player from knowing every possible object in the level. So let's start from the input part. I'm going to the input actions, and here I will create a new input action. Since version 5.7, the third-person template already contains enhanced input configured for basic motion control. So we don't need to have we don't have to set up everything from scratch. We simply add a new input action and link it to the existing input context. So go to the input actions, right click on the empty space and type input action. I'm call this like EA interaction because the template may already have EA interact, so we name it a little differently, and you may notice this little yellow question mark. Don't worry about that. It's simply because I turned on my revision control for the project. If in your project it turned off, you probably don't see that. So when I create my input action, I need to go in the existing input mapping context. I open the AMC default, and here I need to add a new mapping context. So let's click on this plus icon near the mappings. This creates a new drag and drop, and here we need to add a EA interaction. To bind our EA interaction to EK, we need to simply click on this keyboard icon and type E on our keyboard. So that's it. Before I build any trace logic, I want to test the input in play in editor. I can use the enhanced input debug with few console commands. So let's see on it. The console command types like show debug input. Sorry, enhanced input. Press tab to autocomplete and then press enter. Now we see all debug data of our input context. Here we need to find our EA interaction, here it is, and when I press EK on my keyboard, I see that it's turned on light color. So let's me confirm that the action is registered by the system. Also, when you don't want to interrupt the play mode and you already have this debug info on your screen and you want to turn it off, you can use console command show debug reset. Tap to autocomplete and press enter, and everything disappears completely from your screen. So the practical rules is straightforward. Let's test input before attaching a gameplay behavior to it. Otherwise, debugging becomes a little difficult. So now I implement the input event in the player character and attach a line trace to it. Let's go to the third person blueprint and double click on our BP third person character. Here in the blueprint, we need to add a new event, call it as our input action, EA interaction, and attach a line trace to it. Drag from the execution pin and type line trace by channel. So the line trace required a few vectors, the start point and the end point. Let's look at the scheme to understand what is this. For a camera-based interaction system, the start point is the camera world location. Here it is. The direction comes from the camera forward vector. In Unreal Engine is the x-axis that colored with red color. And this vector tells us where the camera is looking. But it doesn't decide how far the trace should go. But distance does. It's a simple scalar value of ray length that we promoted in our Pound blueprint. And for finding the endpoint of our ray, we need to multiply the direction vector by the distance and add this to the start point vector. Imagine that we simply scale the object from the starting point by a distance along the axis determined by the direction. Like in, let's say, some 3D software like Blender, 3ds Max, or etc. So, the formula pretty much straightforward. the start point plus direction multiplied by interaction length. The direction and multiplying by interaction length perform first. So let's implement this in a blueprint. I need to get reference to our camera first. So I'm drag and drop follow camera from our component list. And from this, I need to get the camera location and the forward vector for multiplying the direction vector. Let's drag from pin and type get world location. It is our start point. Then we need to get our forward vector. And now I need to create a distance variable. Let's click on the variables plus and type distance. Let's switch type of the variable to float, compile our blueprint, and then we can set up a default value. I type 400. Compile again. So now we can drag our variable to the field, click on the get distance, and multiply. Connect it in. And as you remember, for the last endpoint, we need to add our start point to our result. And this is our line trace end and start point. For demonstration, I turn on debug drawing. Click for duration and draw time set to, let's say, 2. Let's set up result processing. Tracing returns a hit result. It's pin out hit. And a Boolean value indicating whether a hit occurred. Hit result contains a lot of data. Which object was hit, where the hit occurred, and more. We only interested in the reference to the actor we hit. First, we need to validate that we have hit something. And if so, let's get hit actor, display name, and print it on screen. So I'm drag the Boolean pin for validating if I hit something. Type branch. It's simple if you're familiar with the programming basics. And then I need to get a reference to the hit actor. So to do that, I can split struct pin to see everything that the hit result returning to us. But we also can drag and type break hit result. I prefer this because it's a separated node. There is the pin that we're looking for, our hit actor reference. Let's drag it and type display name. Get display name, the function that we're looking for. And then we can print it on our screen. Let's click compile, everything okay. So you also might be thinking that our camera on the character positioned a little bit strange. So we will fire our line trace directly in the palm. So I want to correct that a little bit. Let's open the character blueprints, select camera boom, and adjust the camera boom offset values. Here, under the camera section, I set up target arm length to 150, socket offset to 050, and target offset to 0050. You also can select the follow camera and change a field of view, or let's say on 70 degree for a better perspective. Let's click compile and test it in game. Now, when I press EK, I can see that my ray is intersecting and I receive a display name of the object that I intersect if I hit something. So I see the name printed on screen. The trace can now find an actor, but finding an actor is not the same as knowing that the actor is interactable. One fragile solution would be to cast to every possible object type: pickup, door, button, chest, terminal, etc. That becomes painful as soon as the project grows. Instead, we must use a blueprint interface. So, what an interface is? An interface is a behavior contract, or glue, or bridge, or pick allegory that you like more. It guarantees the object support this kind of request. Inheritance answers what class family are you in? But an interface answers what behavior contract do you support? So that means different blueprint classes can implement the same interface without needing the same parenting class. So if we look at this scheme, here through the interface we can add as many objects as we want. But in inheritance, we need to switch a parenting class to make a behavior possible. So let's go in the project again. In this project, we create interface BPI interactable that contains the interaction request and the prompt type request. So let's create in our gameplay teaching lab folder a new folder and call it blueprint. Here we need to add an interface. Let's type interface and select blueprint interface. Let's call it BPI interactable. Sorry, my Unreal crashed here, so I'll make a little cut. So the interface will guarantee that an object can receive on interact and also can return an interaction type enum value such as pickup or activate in get interaction type request. So let's implement that functions. First, I simply rename on interaction, then create another one and call it get interact type. This one should return a interaction type. Let's rename it to get interaction interact type. For our interface, it's completely everything that we need. So press compile, save, and close the window. Then we need to add interface validation to our trace. Does implement interface is a function that returns true if the object implements the interface. And after that, we can cast the interface instead of actor class and call the onInteract function in our object through the interface. So let's implement that. The first branch already asking, does we hit something? The next branch should ask, does the object implement interface? So create a new branch. Here we need to create a condition, and to do that we need a does implements interface node. Here we need to select our BPI interactable interface and connect it to the condition. After that, we can cast to our BPI interactable. Don't forget to link the actor ref to our cast. And after that, as BPI interactable, when we receive our ref to our interface on the object, we can simply call on interact function. And that's pretty much it for our character for now. Then we need to create our pickup and changeable object. For do that, I create a new blueprint class from actor. BP pickup will be the name. So here I need to add a static mesh component, select our knife, representing the mesh world. And after that, we need to go to the class settings. And here in the interfaces section, we can add an implemented interface. So we type the name of our interface, BPI interactable. And this shows us the interfaces function on the object. For implementing this function, we can simply double click on it. Here in the get interaction type, we should switch it to a pickup. And on the onInteract function, when we double click, it brings the event in our event graph. And here we can implement the logic of our pickup object. So the implementing inventory system isn't a part of today's lesson. So I simply drag and call the node print string. And in this node, I will print added to inventory. After that, I wanted to hide my mesh instead of deleting. Check the checkbox, and also we need to disable collision. So set actor enable collision is the right node for that. Leave it like that because it already contains the needed behavior. So let's create another one object. And let's duplicate by Ctrl D this one pickup, change the name to changeable. Open it, and we need to switch our static mesh to our Venus. Make it a little bit smaller. Compile. We already has the interfaces on this object because we simply duplicated it. So we duplicated the implemented interface and we can find it here. So for the get interaction type, we need to switch it to activate, and for the on interact, we need to double click again, delete the previous one, because we need to be sure that we call the interfaces function. And for the implementing the changeable logic, I need a simple flip-flop variable. And I create a new one bool, call it toggle. I will get this toggle, create a new branch, connect our variable. And for the changing material, I need reference to our static mesh. Then I need set material node for the true and for the false scenario. So let's add here a new reference and connect everything. After setting this material switching, we need to switch the variable to implement the flip-flop. So we again get our toggle, reverse it by using not boolean, and then set the variable again. Connect everything, the both nodes, and a new variable too. Here in the set material nodes, we need to choose proper material. So the default value for our toggle is false. So when we will be checking it first time, we go to this material. So here we need to set a different type material of our statue, because for now it contains mi yellow material. So mi yellow material we need to switch when we have a toggle with true value. So let's choose this one here and default metal here. So that's it for our object. Let's add it to our level and check everything. I will rotate a little bit our knife and drag and drop it to the floor with the End key on my keyboard. So let's check everything. Voila! Our object switching, and we can pick up our knife and receive a message that it's added to inventory. That's proved the main pattern. Same input, same trace system, and interface request, but the different object reaction. So the player still doesn't need to cast a specific object class. At this point, the trace works correctly, but the player experience is still weak. We cannot see clearly what we are targeting. This is where we add the crosshair and prompt UI. The prepared widget is VBP crosshair. It uses a default crosshair texture and an interactable crosshair texture. So the standard setup is create the widget at begin play, at begin our game, and add to the viewport. So after that, we can store the reference and update the widget later. Let's implement that. We need a bring to our blueprint begin play, then create our widget, select proper widget with VBP crosshair. Then we wanted to store this as a variable. This doesn't matter what you do first, add viewport or variable, because it's really depends on your style. So I rename the variable to hat and then add it to a viewport. So let's compile and check. Now we have the crosshair. Now I wanted to refactor the trace. The first version already traces only when pressing E. That is useful for learning the math, but it's not enough for a prompt system. Crosshair already gives orientation. The interactable state tells the player that the object under the trace can respond to interaction. The prompt should appear before the player presses interact, not after. And if the prompt should appear while the player is looking at an object, the action has to run before the key presses. Our prepared UI already contains an update logic and update UI function. This function must receive the interaction type that we set up before. This value will be updating our visibility of our elements in UI with prompt text from our string table. So I wanted to move my trace, every trace logic, to the event tick. Let's disconnect that by clicking with hold it Alt. And here we want to disconnect the onInteract because we should do that in our enhanced input action. Here we need to store our variable, what actor we last catch as interactable. And as BPI interactable interface, we wanted to get interaction type. So here we can update our UI. For that, we need a reference to our HUD, get the HUD, and call function update UI that already contains it. We connect interact type to this node, and after that, we can update our interactable. But if we doesn't receive a hit on object, or our object under the crosshair doesn't implement the interface, we want to update UI with the non-interaction type. We also need HUD reference for that. And we wanted to set the variable to the node. But for that, I recommend to do that thing, convert to validated get, so we don't update it every tick. We just simply validate that does we contain in our variable something, and if so, we can just reset it to nothing. And for the interaction, we need to cast to our, first of all, validate again our interactable. And if we have something, we can call the last interactable with the cast to our BPI, and then call the interaction. Let's check everything in our... For now, we can see the interaction prompt, and when I move my crosshair, it disappears. So I can easily interact with everything. And if I turn off my debug, it will be a little bit clearer. So for now, we have a good system. So let's recap everything. Let's summarize the system. Input asks for interaction. The camera trace detects the current target. Hit result tells us what the trace found. BPI interactable removes hard class dependencies. Each object owns its own reaction. The UI communicates the current interaction state and prompt text to the player. This is a small prototype, but the structure is production-minded, readable, reusable, and friendly for designer extending it with new interactable objects. Thank you for the watching.